I just shared the link, so you should be able to go here. If you click on the link, it will take you here. Just click on this practice SQL Query1.sql. Just click on this. That's it. Simply you copy paste everything into SSMS, okay, and copy and paste it here. You create whatever database you wanted. Okay, for example, you want to have some, this in my case the database name is use sales, and first and foremost, right, so you need to, first step is first select the database, which database you wanted to create the tables. It is always good you drop the tables if it is already there, and create the tables from the beginning. First you need to create the department table, it is mandatory, and then you need to create the employee table. So this is the order, you need to follow it strictly. Next, go here and then simply select all this insert statement, go till the end and select it. Not this one, yeah, anyway, if you copy that one also, not a problem. That's it. So simply what you do is Control A and then click on execute, or everything will get executed one after another. Okay, but you don't have to execute this one. This is not required. This for testing purpose I did it. If you do it, there is no harm. It is not going to cause any issues. Once you are able to execute all these queries, right, the data will get these two tables will get created and the data will get loaded into these two tables. And finally what you do is select, let me do one thing, select star from EMP and go, and the next one is select star from depart, next line go. So now you select these two queries and click on execute, and if you move this up, you can compare the data in these two tables, employee table and department tables. You can see all this data here. Fine. The next one is, now the data is available. Fine. The next what we will do is we will start work on the inner join. Okay, now I just show you how to perform inner join. The common value between these two tables will get loaded. So what I'm going to do is I'm going to say select e.ename, comma e.depart number, comma e.sal from emp as e. Okay, so I'm going to bring this to next line and I'm going to say inner join with my department table, depart as d. It is always good if you use some alias on e dot depart number is equal to d dot depart number. The common depart numbers, right, the depart number values common between these two tables will get merged, will get joined. Okay, the uncommon value, what is the uncommon value here? If you look at the depart number in both the tables, in the employee table you can see the depart number 10, 20, 30, only 10, 20, 30, and if you see here one extra department is there, 40. So from this we can understand that none of the employees got assigned to the depart number 40. Okay, so in that case what will happen is it will show all the employees got assigned to d dot d name, department name. Look here, all the employees belong to, for your reference sake, you can type the depart number also, column. This is from the employee table. Okay, and d dot d name. You click on execute it will show you all the employees belong to 10, 20, 30 department. So the depart number 40 was not displayed here. Okay, demonstration. This is what inner join. Inner join is the common values between two tables. That is what inner join. Once again, I'll just show you. So you have something called Venn diagram. So in the Venn diagram, you have something. Let's say 1, 2, 3, and here you have 3, 5, and 2 is there, right? So in this case, what is the common value between? So here 1 is there. Here 1 is not there, 2 is there, and 3 is there. So 2 and 3, these are the common values. This is what your inner join. The common value between these two data set. So in this case, let's this is my depart number and this is my depart number. The non-common values 2, 2, 3, the 1 is not displaying and 5 is not getting displayed, right? It is not getting displayed because these two values are not matching between these two, hence it simply ignores this one. So this is what inner join, common value between two tables. In this case, we have used the department table, right? So the department number as the common column between these two tables. This is what inner join. In the interest of time, I just copy paste this and I just copy paste this one here again. So here I say left join, left outer join. So what is going to happen in the case of left outer join is, okay, so here I'm going to change the order of the table now. Okay, let it be there, and I'm going to do left outer join, and next one is I'm going to say right outer join. Since our data is slightly different, right, so I'm going to use right outer join. So when I do this one, this is my right outer join. All the values from the right side table. What is the right side table? Department table. All the department number from the department table will get displayed, irrespective of the fact that the department number which is there in my department table, that is not there in employee table, will also get selected here. So look here. In the department table, we have seen the department number 40, which were not there in my employee table, isn't it? So in that case, what happens is, in the department number is showing null here, employee name. Okay, there is no employee got assigned to department number 40, and there is no department number 40 is available in my employee table. E is nothing but the E represents, E is an alias for your EMP table. Okay, and the department name is getting displayed. Okay, and then the salary, because none of the employees got assigned to the operations department, which is the depart number depart number is 40 here, hence the salary is also null here. So if I come here, so in the case of right outer join, so inner join is common value between these two, and the right outer join is only on the right side. So you have A, B, let's say you have 1, 2, 3, and here you have let's 3, 5, 2, same value will take it. So matching value between these two tables, and in that case what will happen, 2 and 3 will get selected, and the non-matching value from the right side table. So 3, 5, 2, all the values from your right side value get displayed. Okay, this is your right join because the B is on the right side of this Venn diagram. Okay, and if you do the left outer join, what will happen? So 2, 3 is common, but 1 is not common, hence this 1 will get displayed. So entire value from your left side, that is your left join. Entire value from your right side is right join, and inner join is common value between these two data sets. Hope you understood. So the right join is this one, right? So the left join is this one. But here in this case, when you use the left outer join and right outer join, when you change the order of the table, obviously the output will also get changed. Instead of putting employee here, I put depart as D here, and here I put M. So what will happen? So since the left side is department number, depart table, right? The output will get changed now. If I execute this one, same query, but the order of the tables are different now. But here left outer join, but here right outer join, right? So both the output of these two right queries are same now. Okay. So remember that in the case of left or right outer join, if we change the order of the table, here department, and here if you put employee table, the output will get changed. But you need to remember these things very well. So this is right outer join, all the data from the right side, left outer join, all the value from the left side. So in this case, left outer join, right? So we are doing left outer join on the left side, all the value from the department table, right? So all the value from department table, look here, department name, everything, and also the matching value between these two tables. Okay, and here here if I execute these two things, let's see what happens here. So in this case, all the values from the employee table, all the values in the sense, all the department number from the employee table. Look here, all the values. So all the values from all the department number values from the employee tables are 10, 20, 30, right? That's all. In the employee table, you don't have the department number with 40, right? So hence all the values from your employee table, especially the department numbers, are getting displayed. Whereas here, the table order got, so in the place of employee I put department, in the place of department I put M, but I'm using the same left outer join. So all the department number from depart table will get displayed here. Ideally we can use D dot department number here, so that there will not be any confusion. So if you look at this this first query, this is pretty straightforward, right? All the depart number from the employee table. In the employee table, you have the depart number starting from 10 to 30. That's all, right? Whereas in this case, here also I'm using left outer join, but in the left side I have the department table. All the department number from the department table. Look here, 40 is also included, but there is no matching values there in the employee name table, employee table, hence it returns null. Hope you understood the difference between these two, and remember that even in the case of left outer join and right outer join, if you change the order of the table, the output will vary. But this is the concept, this is the idea. The idea is pretty simple. Next one is, I'm going to show you the full outer join. Even in this case, returns everything. Full outer join is, it shows all the values, right? All the values from both the tables. It is basically doing both all the values from the right side, all the values from the left side. That is what it does. Look at all the values from my employee table and all the values from my department table. But there are no duplicates here. Okay, there are no duplicates. Here also I'll put, here I put D dot depart number. Right, that is the difference between these things. This is basically full outer join is nothing but your union. It's the set operator union. Okay, you have something called union operator, so it is doing the union here. Okay, and or else you can do something like this. Select D dot E dot department number, or we will do one thing, select star from emp union. Anyhow, I will tell you now. I'm going to select star. You cannot, it is not the right way of doing it, but still, if you do union, what will happen? It is going to throw an error. All queries combined using a right operator must have an equal number of X in their tolerance. So here the number of columns are different, here the number of columns are different. For example, probably what we will do is depart number from this table and then depart number. These two are common between these two. If I do union will remove the duplicates. Union will remove duplicates. So 10, 20, 30 is there in my employee table and department table. In addition to that, we have, here we have 10, 20, 30, right? In the employee table, whereas in the department table, we have 10, 20, 30, 40 is there. If you join these two tables, it will remove the duplicate values. So here 10, 20, 30 already it is there. Here the 10, 20, 30 got removed and only the 40 got included along with this value 40. This is what your union. And similarly, let us look at the intersect. Intersect is the common value between these two tables. These are my this is my intersect, common values between these two. So this is more or like your inner join. This is like your inner join. This is like your full outer join. And the next one is I'm not sure if minus is available here. MySQL, it is not available. Yes, 1 second, I just executed this. So I want to execute only this one now from employee minus. Oh, okay, this is not considering the minus here. Or yeah, so look here. If there is a syntax like a minus, it would have shown you in green, blue color, right? There is nothing called minus is available. Where depart number not in this one. Okay, where department number, or okay, let me do one thing. So here employee department number, so 10, 20, 30, 40, all the things are there. If I change the order, something like because in the employee table, whatever the department numbers are there, all those things are available in my department table, hence it was not returning anything. Even not in is not good. Look here, I want to do A minus B. So you studied the A minus B, right? So the values that are there in department table, which is not there in employee table, as simple as that. So the minus operator is not available in SQL Server also, like in MySQL. Only in Oracle, minus operator is available, to my knowledge, okay, because I worked extensively in Oracle and MySQL also. And DB2, I'm not sure. DB2 is also another type of RDBMS, but in SQL Server, minus is not available. Instead, we can use this one, A minus B, instead of minus, right? Minus is not available, hence you can use not in. So whatever the department number that are there in my department table, which are not there in my employee table's department number. You know very well, in the employee table, the department numbers are available from 10 to 30 only. 40 is not there. But here 10, 20, 30, 40 is there. So what is the uncommon thing? The 40, right? That is the one. So now we will try something else. Here's something called except. Except is also similar to this one, right? So the same thing. So I just show you here. See, except is something like this, except and not in. For example, we have A here, A, B, B here. Let's take the same example. This is my department table and this is my employee table. And here I have 10, 20, 30, 40 department numbers are there, whereas here I have 10, 20, 30. So, right, so the department number, select all the department number from this and then except employee table. That means, right, so the common value, right, uncommon value, right? So these values are common, but this is uncommon, right? So the distinct value between these two tables are called your except. The except of the department table and employee table returns 40. So which is the distinct row from the department table result set that does not appear in the employee table. To tell it out in the formal definition, right, that is what is happening. So both of them are doing the same thing, not in or except. But again, if you change the order, the output will change, even in the case of not in, right? So even in the case of except, the same thing is applicable. We will test it out always. Instead of going by theory all the time, it is better you can test it out. So what is uncommon between, we can use this term. What is uncommon between these? Nothing, right? The employee table, what are the department numbers are there, that that are available. There is nothing uncommon between these two. Uncommon value between these two data set, right? That is what the except tells us. So or we can say this way, right? So we can, in the Venn diagram, how they specify, right? The same thing. I'll just draw it one more time. Department and employee table, and here I have 10 and let's here I have 10, 20, 30, and here I have 20, 30 and 40 is there, right? What is common between these two? 10, 20, 30, right? And except the common, this side, right? If I say, I did not highlight here, I did not put the cross line here, right? So that means except the common values between these two data sets. So what is the except the common here? 40, right? It returns the 40. This is the one. So this is called your except. That is what the distinct is. But changing the order also matters a lot here, right? So it is showing different thing. That is what except. So except and or alternatively you can use not in also. That is, and next one is the self join. Joining the table to itself is called your self join. So what is self join? That's what I told you. So self join is joining the table to itself. For example, in this case, select. What I'm going to do is select e.ename, comma. I'm going to use the same table as m.ename as manager, something like that, and then from emp as e, and here what I'm going to do is I'm going to use something called left join, emp as m on e.emp number is equal to m.mgr. In this table we have something called mgr, the employee table. We have something called order by, I say, manager. Okay, see here I'm using employee table, right? So I'm doing the left join with the same employee table, but the alias is different. So but in this table we have two columns, employee number, manager mgr column, these two columns having the employee number itself, but two different columns, right, in the same table. So this is something like hierarchical structure. This is called as a hierarchical structure. In this case what happens, we will see that in this case what happens is the Smith null, manager null, Clark null, and King manager is Blake, and King manager is Clark, Jones manager is Ford. See, within these two columns, right, the employee number and manager. In the case of employee number here, I just show you here. Whatever the employee number, I just put the okay, I'll just put the m.emp number also. Sorry, m.mgr. These two columns, emp number and mgr, they store the same employee numbers. So which means 7839 for him the manager is something else, and 756 is 7938. Okay, because it is not showing, it is confusing. Okay, one second, let me just show you here. We will remove this one, it is causing confusion. One second, I'll tell you why. Here what happens is, for the King, right, the Blake is the manager, and this guy King has two managers, Clark and Blake, and Jones manager is Ford, and Blake's manager is James. Okay, and King's manager is Jones, and King also has, maybe this guy employed is same thing, right? Okay, left join. So what I do here is but inner join, it will not be helpful here. 7839. So again, so here, right, so this is not required. See, what happens is, in this case, both the employee number, manager, they mentioned the employee IDs. For example, here the employee table, right, we have emp number and mgr number, right? So mgr. For example, your employee ID is 1005141, and your manager employee ID is 1032. But 1032, and here the manager is null, which means, so he is not reporting to anybody else. Okay, maybe he is the CEO of the company, right? That's the reason when I use left outer join here, what happens is, for these guys, there are no managers. Okay, here, and look here, Scott has no manager, right? But Scott has a reportee Jones, and Smith has a reportee as Ford. So this is what your self join. So joining. See, in this case, both the left side and right side have used the employee table, but the alias is different. Here M and E, but here I'm going to join in the same table with different alias, but the column names are same. See, sometimes what happens is, instead of joining the two tables based on the common column, right, the same table itself, within the same table itself, we are using these two columns to join. So these two are common column. You just think that way, right? So to retrieve this one, this is the one you are getting it here. But if you individually query the data, right, you will get to know the employee number and manager, right? So you will get to know that. So you just probably try that. So this is what self join is all about. Joining the table to itself is called self join. Rarely we will be using it, but you remember the all these operators, right? Minus is not available. Instead not in, you can use it, and or except you can use it. And the next one is full outer join, inner join, right join. All these things you can use it based on your need. For example, as I quoted in the last session, if you want to find out any exception between the tables, right? So you can use the right outer join, or if you wanted to see the products, whichever products you sold it and whichever products you did not sell it, in that kind of situation also you can use left join. Okay, so I have explained you with the use cases. You can try that one. Anyhow, you will, when you keep practicing it, you will learn all these things. Fine. What we will do is we'll take a short break, and short break in the sense, let us work on the assignments. Okay, simple assignment. Let us start work on it. All of you, please keep try along with me all these exercise. Okay, so that when you start with simple, right? Since majority of you are not familiar with the SQL query, right? The basics, can start practice along with me. Let us start with a simple one. You let us do one thing. I'll just go to this one. Select star from. Simply you select all the values from your employee table. How do I select all the values? Star from EMP. But remember that you are not going to use star in the real time scenario. Don't use it. Okay, and instead what we will use it, we'll be doing is select top here what we will do is top 3 records, first 3 records. I just want to see the top 3 records. How do I see that? Let us start with a very simple one, and then let us increase it. So now we can see that the employee number 756 is. How will you display only the I want to see the entire record for the employee number 756 is. How can you query that? Select star from EMP. So that's where the var is very much helpful. EMP number is equal to 7566. Press F5. Look here, if you wanted to select a specific row, you need to use this var clause, right? Based on this condition, it will retrieve that record. And so this is one thing, and then this is equal sign, right? And if I wanted to use something like greater than sign, right? So comparison operator. So let's say instead of this one, I'm going to say salary is, we have a column called salary is greater than, let's 2000. So those employees are getting salary greater than 2000. I want to see only those employees. Look here, here the employees' salaries are more than 2000, right? But we want the data to be displayed in the descending order. Okay, those getting salary more than 2000, we want to see it, and of those subset of the data, which person is getting higher salary? Order by. That's where the order by is nothing but sorting. In Excel we do sorting, same thing we do it, order by sal, and you need to use descending, DESC, short form. You don't have to type the entire thing. By default it is ascending. Look here, the king is getting higher salary. Next highest salary is drawn by Ford and Scott. Fine. So this is how you can start your journey. Okay, with right. So write a simple queries, simple queries, and slowly we will progress with. Now we want to see the unique jobs. I want to see the unique jobs in the employee table. Select which function that I'm going to use in a distinct, right? So unique job from EMP. Try side by side. Okay, And also we discussed about various operators between, not in, is, null. Likewise, we have used different operators, right, based on which we can do the queries. Okay, and also we have something called higher date. So how do we query the date column? So for example, in this case, we will just, so higher date is 1980, 12, 17. So 1980 seems to be the minimum date and higher date, and maximum higher date seems to be somewhat here, right? 87 maximum. So what we will do is, in this case, let's say my manager is asking me, can you share me the employee details who joined between so and so hire date X and Y. Okay, where, in that case, what will happen? They are putting some condition, right? You need to use where hire date between 1981 96 and let's say 1981, sorry, year 1981 02 0204, 1981 07 to 013. So they wanted to see the employees, those joined between these two periods. Will this query work? Yet yes, it is working, right? So between these two, so 181 to 4 and to 1981 7, right? So yeah, between these two dates, right, whatever is there, it displays 1981 0713. and 2, right? So 1987. Okay, that is 11. Okay, 11 17. Yes, 11 17 is also coming, right? Starting from this two, between these two dates, whatever is there, starting from this two, ending this one, whatever is there, it is fetching it here, right? It's correct. So this is how we can write a query against your date column. Okay, so now you understood in the where class, in the where class, based on the condition whatever you specify, the output is also getting changed based on the output, right? So based on the where condition, right? In the where condition, higher date column used, and then between is an operator. Okay, this is an operator, using which we can do that. So the next one is, for example, I just wanted to see all the employees, those got hired only by the year 1981 or something, right? So to higher date, where but I don't know if to-char will work here, to-char, or else we will have to use the date part, higher date. So look here, it underlines it, right? So there is let me just higher date. So if you specify, this one will not work. No, this is not the correct one. So what I am going to do is, let me do one thing. I just go and check the EMP table. Where is the EMP table? The higher date is the date column, right? So here interval date, for example, here I just go and say year and higher date. even so. Here let me do one thing. Hide it. MP, let us do one thing. Yes, it is giving the year, right? So hire date. So in this case, based on, you can try like this step by step. Instead of typing the entire date, month, year, right? So if there's somebody is asking you, hey, can you give me all the employees who joined by 1981 also, right? So where date part hire date is equivalent to 1981. Look here, these employees joined on the 1981, right? With a single query, and you can get everything. You don't have to write everything, right? So you can give it. So, or you can use the between, or you can use the date part. Date part is available in Power BI also. So likewise, you can try all the queries, okay? And importantly, the what is that? The star wildcards, right? Wildcard function also you can use it. Employee name start with something, right? Start with this one, and the next one is what we will do is okay. So display, now I want you to join the employee table and department table, and get me the employees, or display the employee name and their job and then the department number, and those work at location Dallas. So let's say in the select star from EMP, sorry, not EMP, depart Dallas, right? Display all the employees who work out of Dallas, their department name and the employee name. I want you to display it. So how can you do that? Can someone, or why don't you all give it a try and share the query, right, in the chat window, so that I can make sure that you're all practicing it side by side with me. So display, I just type it here. And if you are comfortable with this, I will move ahead with little advanced part. What is subquery, scalar subquery, multi-row subquery, and what is correlated subquery? I'm going to jump on that. Okay, once you are comfortable with this, I want to display the employee name, comma department name from employee and department table. Only when you join these tables you will get department, right? So where the location is equivalent to Dallas. Okay, this is maybe pseudo code for you. What is pseudo code? Just it is not the actual code, but it tells you the flow, how to do that. Can you all write a query? Can you send it quickly in the chat window? Simple. In the where clause, you need to join both the the common column between these two tables, and then you need to add one more condition, where location equal to Dallas, right? Anuradha, why don't you send it quickly? See, if you have joined from your mobile, not a problem. Just let me. Those of you connected from your laptop, right? Please send it quickly, so that we can. And then the next question to you all is, find out all the employees whose salary is more than the average salary and by all employees. This is little bit tricky. So how can you do this? From depart, yes, your query is correct. Aruna, partially it is correct. It is not fully correct because you are joining the two tables. Whenever you join the two tables, you need to specify the common column between the two tables in the where clause, right? So you need to specify something like that. Whatever it may be, right? Only when we make mistake, we'll learn. Even don't think I don't make any mistake. Okay, so I make mistake. We all make mistake. And here, so you can specify like where you need to specify. This is what most. This is where most of them they get emp dot depart number. What is the common column between these two tables? Depart dot depart number. We need to specify and. First you need to link these two tables. How will you link employee and department table? Why you need to link? Because these two columns are coming from two different tables. Hence you need to link these two tables. How do you link the two tables? What is the common column between these two tables? The depart number, where emp dot depart number equal to depart dot depart number, right? So yeah, inner join, right? So and locate equal to Dallas. This is the ANSI SQL, like Srinivas pointed out, right? So what we will do is, instead of doing this way, we'll use this one, right? So inner join. So this inner join department on, instead of using where here, on so here, how will you use this one? Will it work? Yes. So in both the cases, we will compare the output. Both of them returns the same output. The Smith, Jones, Scott, Ford, right? Before we jump into the SQL execution plan, all the things, first I want you all to be familiar with these queries. So in this case, it requires the, I just, this one I remove it here. So you can use this way, or you can use this way. Okay, so you don't have to, better you can stick to this one. Okay, most of them they use this kind of query only. Okay, T-SQL, something like that. Okay, this is the ANSI SQL, and this is kind of a T-SQL or something like that. It's not a T-SQL. This is the one used in practice by most of them. In the olden days they use where clause and all. You can use this one. Okay, inner join. Okay, the common value between these two. Inner join is nothing but the common value, right, between these two tables. You join it and then return it. Okay, return the common values, and then the location is Dallas. This is the one. So these four guys are working from the Dallas location. Next one is slightly complex one. Find out all the employees whose salary is more than the average salary earned by all the employees. How can I do this one? So find out all the employees whose salary is more than the average salary earned by all the employees. First we need to break this into two smaller problems. Find the average salary. First let us find the average salary. Second one is filter the employees based on the above output, right? So the above output. So in this case, what I am going to do, select AVG is a function, it's an aggregation function which is already available in SQL Server, EMP. So this is the average salary. So what I am going to do is, in the interest of time, I just copy paste this, select star from employee, where salary is greater than 2628. Pretty straightforward. So these people, the average salary, what was that? The average salary of all the employees 2628, which all, right, this is the average salary of all the employees, okay, and which all employees are getting more than the average salary. So these guys are getting 2,975, 2,850, 3,000, 5,000, 3,000. And similarly you can try minimum salary, right, to find out all the employees whose salary is more than the minimum salary earned by all the employees, more than the maximum salary. Can we do that? So that is a different thing. We have another query for that. We will see that. So now we have to write two different queries. First you need to find out the average salary, and then you need to hard code it here, the average salary. But this is not the right way of doing it. Why it is not the right way of doing it? So as the number of employees get, as more employees joining your company, the number of records will also get increased. More the employees they join, and the salary also differing. And if you hard code it, what will happen? Right? It is not the right way of doing it. So instead, what I'm going to do is I'm going to select star from EMP, where salary is greater than select average salary, the same query, okay, from, I'm combining both the queries into a single one. Now let us check these two things at this moment. Testing is very much important. So everything is correct, matching, right? Both the queries. But what is the difference here? The second query is very dynamic. Even later point in time, if you add 100 employees or 1000 employees or 1 lakh employees, this query will find out the average salary automatically, and then the output of this query will drive this outer query. Whatever you see, this one is your outer query, and whatever you see here is this is your inner query. This is called inner query. This is in general called as the subquery. This is called your subquery, and this is called your outer query. Okay, outer query and subquery. So what will happen is, in this case of subquery, the subquery will get evaluated first. This one will get executed first, and the output of this one will drive the outer query. This is called your outer query. This is called your inner query. We can say that way also, inner query or subquery. The output of this one will be driven by this. The output of this one will drive the outer query. So this is called your subquery. Okay. But so what is we can say it's a subquery or a nested query, right? So we have used a query with another query, hence we can call this a nested query. A query placed with another SQL query, that is called your subquery. You just remember this. In this case, what happens is, okay, this is called your scalar subquery. In the subquery itself, you have something called scalar subquery. What do you mean by scalar? See, in the data science also, I'll be using the the terminology. Scalar is a single value. Okay. So in this case, the average function returns only one value. I just remove this. Data scientist students, right, in this batch, please remember this. Okay. So this is called scalar subquery. So in this case, select star. I just split it like this. This is my outer query, or we call this a main query. And this is called your subquery. This is called your subquery or inner query. Got it? So whatever you see here, right, this is your outer query, this is your inner query or sub query. Both the terms are same only. Okay, don't get confused with the term. Some people they use interchangeably outer query or main query. Both of them are same. This is your sub query. Sometimes we may have to write the nested query or sub query like this. The query inside another query is called your nested query. We will have to use these kind of queries. Okay, so since the sub query returns only one value, we call this a scalar sub query. Scalar sub query. Fine. So when I say the scalar sub query, right? Okay. So when I say scalar sub query, the next thing which comes to our mind is multiple row sub query. So if if my sub query returns only one value, that one is working. Is there any way multiple row sub queries are possible? So can I nest a multiple row subqueries that can return more than one row of results to the parent query? More than one row of results to the parent query. Yes, that is possible. But in that case, we have to use in function. We have to use something called in, or not in. In is not a function. In, all. You need to use this kind of comparison operators. All, any. Okay, I'm talking about multiple row subqueries. In order to do this one, we need to use this one. For example, I'm going to do the same thing. Select star from EMP, and let's see here what I do is, instead of this, I say ename employee name, comma, job, comma, sal. I don't want everything. Fine. And here I say greater than all. Okay, all. Select sal from EMP. See, look here. Only when I use aggregation function, it returns only one value. Here I am not using any aggregation function, but I am going to say job is equivalent to, what is that? Here we have analyst manager, right? So let us try with manager. More people are there. Let me do one thing here. Manager. So now we will try this one first and to validate whether it is doing the correct job or not. So I need to remove this one. 2975. This query returns 3 rows. That means 3 employees or managers, their salary is this one. So these 3 records will drive the outer query. So in this case, all the 3 values, you need to use all operators, comparison operators, right? So there's whose salary is all the employees where salary is greater than these guys, right? So what I'm going to do is, I'm going to use all function. So these guys, 3 guys salary is more than the manager's salary. This is multi-row subquery. Got it? So this is how we can. So we can use all function, and we can use any function also. So we have all, any, in function, you can use it. For example, those employees are let me do one thing. Select star from EMP. 30 is there, right? So employee number 30 is there. So I'm going to say select star from, because this is the best way to start the employee simple table, right? So if I put you directly with the adventure works, right, it will take time for you will get you will get tensed. Not equal to 30, right? So you're not equal to 30, and sorry, here, and salary is greater than, I'm going to say any distinct, let me use this one from M, where depart number is equal to, say, depart number. You can do it that way also. Depart number is equivalent to 30. So in this case, what I'm doing is find the employees, those not belong to department and 30, and whose salary is more than any one employee working in the depart number 30. Sorry, this is 0, right? 1 second, let me just. Select distinct, we will break this into two different things, and then we will see here. So this employee salary is 950 and 2850, and then we will see these employees, okay, and select, I am going to say the salary from EMP where department number not equal to 30. So these guys, right, are the employees, those do not belong to depart number 30. These are the salary, okay. We want to see, if so in this, right, whose salary is more than any one employee working in department 30, right? So that is what we are trying to say. This is a little bit complex one. You can try it out. So, or you execute these three, always you execute these three, and then you can validate the output here. So here these employees are these employees belonging to the depart number 10 and 20, okay, and this one, the second one is what, the second one, this distinct, the where depart number equal to distinct salary, the distinct salary is this one, and here any distinct salary from depart number 30. So now at least any one of the employees salary, right, is more than the employees those work out of this one, the depart number 30, okay. So now if you combine these two things, you are able to see this. So look here, in this case the depart number equal to 30 is 950 and 2850, but here, right, so it is any, right, greater than any, at least, right. So this guy's employee salary is more than 800, right. So 2945, it returns everything. So the any function. So this is called your multi-row subquery. You can you can split it, and you can just try to, you can try with with some other combination also. So in a nutshell, this is what called as subquery, and apart from this we have something else called correlated subquery. We have something called correlated subquery. So it is a subquery that uses values from outer query. It is opposite of your plain subquery. This is called plain subquery, and this is your correlated subquery. In the interview, they'll ask you what is the difference between subquery and correlated subquery. See, though in the case of Power BI interview, the number of questions are less when it comes to SQL queries, but these are the fundamental thing, you should be knowing it. In the case of subquery, the subquery will get executed first, and then the outer query will get executed based on the result produced by subquery. Okay, within this subquery you have two types. One is scalar subquery and multi-row subquery, and we have something else called correlated subquery. So in this case, the outer query, right, the subquery uses the values from the outer query. Okay, so now the question is, what is the difference between subquery and correlated? In the case of subquery, the normal subquery is executed only once. Remember, look here, in this case what happens, just look at this diagram. Okay, this one will help you to understand quickly. So look here, this is my inner query. My inner query is something like this, which is nothing but my subquery. Okay, and here this is my outer query. This is my outer query. Select employee number. Instead of specifying clerk here, okay, let's say you are using select the 7369. Yeah, select employee number from where job is equal to employee number where job is equal to clerk, right? So in this case it is a straightforward one, but in the case of inner query, what happens is, let's where job is equal to select job from emp where emp number is 7369. Ignore this one. On the right side you have this query here. So in that case what will happen is, this guy belongs to which the what is his employee number 7369, and what is his job, clerk, right? First what will happen is, this inner query will get executed. You just assume that the inner query is here. In the place of clerk, this one is there here. I just hard coded clerk here. Okay, so what will happen is, the inner query will filter this one based on this condition. So the job for the employee number 7369 is clerk, hence the this one, the inner query's output job will be used to filter my employee table. So in this case, clerk, how many number of times are there? 2 records, 2 employees, job is clerk, and then what it does is, it produces this output. Okay, basically the inner query helps us to drive the outer query. So in this case, the inner query returns clerk. If you substitute the value clerk directly here, so all the clerk related employees get filtered, and only those clerical employees will be produced as an output. So the inner query is executed once, and then based on this, outer query will get produced. So the subquery is executed only once here. Whereas in the case of the correlated subquery, right, the subquery is executed multiple times for every row of subquery. For every row of subquery, the correlated subquery will get executed multiple times. I'll just show you with the same example. Here I have used the, look here, salary, right, the same thing. I just write it here itself. Select star from EMP, right? So I'm going to use something like as E, where salary is greater than, select average salary from EMP. I'm going to use where clause here, where depart number is equivalent to depart number of this subquery is equivalent to E dot depart number. So for every employee's depart number from the outer query will get matched with the inner query's depart number. For every employee, this subquery will get executed. So if I execute this one, what output am I getting it here? Now if you compare these two things, 7839 and 7902 and 7839, 7902 and 7788 and 7566, both of them are producing the same output, but which one is more efficient? Which one is more efficient here? This one is more efficient, right? I just so here this one is outer query. Query cost is 69%, whereas it is 31%. The query 1. What is the query 1 here? Query 1 is my subquery. This one is correlated subquery. If you see here, which query's cost is high? The second query's cost is high, right? Higher the cost, more the time it will take to execute, right? If you hover the cursor here, right, you can see that compute scalar cost is 0%, cost is 50% here, and clustered index scan, it does this, and then you say, but in simple term, right, at this moment we will try to understand later. At this moment, right, you just focus on the cost. Query cost for query 1 is 31%. So with this itself we can understand the correlated subquery is not much efficient. Better we can use the non-correlated subquery. Now the question is, can I replace all the non-query with the plain non-correlated subquery? There are situations, right? So you cannot rely on you cannot use everything using the subquery itself, like the non-correlated subquery. Some cases you will have to use the non-correlated subquery, which we will see it later. Okay, at this moment I don't want to dump so many things on your head. Fine. So now you understood the subquery. Subquery is kind of a subquery and non-correlated, correlated subquery and non-correlated subquery. Both of them are nested subquery. We can say it's all nested query. But whatever you do with the subquery, right? Without the subquery also you can do it. I just go and, for example, in some cases, okay, in this case it is greater than is required. For example, I'm going to use another query. Select ename from emp table. Where department ID, right? So where depart number is equivalent to select depart number from depart where location, right? Locate is equivalent to, let's Dallas, right? This is also a subquery, right? So here, those employees work out of Dallas location. We can do it. So the same thing. What I'm going to do is, sometimes you can, instead of writing the correlated subquery, you can use the non-correlated subquery like this, right? The performance will be good. And sometimes instead of using the non-correlated subquery, we can use the join condition itself, where department number is equivalent to this one, right? So emp, I say emp as e, and e dot department number. I just write my own way of writing it. Anyhow, I will just change it, and d dot depart number. And depart as d. This one I think we already tried, right? So locate is equivalent to Dallas. So So here 4 employees are there. Let us just test this with simple join condition. So both of them produce the same output. Correct, both of them are producing the same output. Now what I do is I just select Control L, right? Query 2 is 46, second one is, look here, 54%. Which one is efficient? With a join condition, instead of using the subquery, I can use the join condition. With the join condition itself, now I can see that this one is doing pretty good job, right? The cost is lesser, but whereas the cost is higher. So you cannot rely on the execution plan also, one time. So I will try to run it once again. I just will try to run it 4654. It consistently shows 4654, right? Okay, more than one times you can try it out and then see it. Yes, it shows this one is far better, this one is less. With the query cost itself, we should be able to understand. Next one is you need to understand the way how it executes. So nested loops, inner join, it is doing the inner join here. Here, even in this case also, it is doing the inner join, that is what. But here it uses cluster index scan, cluster index seek, and then the part. So here what happens is asset called 0, stream aggregate, and pk department, and cluster index scan. So this is bit difficult to understand this one, but over a period of time you will be able to understand in what flow the query is fetching the output. But the simple thing is, when you hover the cursor here, you can see sometimes the index can also pretty dangerous one. If you use index for entire record, it will slow down the performance, right? But here we are filtering the data, but depart number, pk department. See, primary key is a depart number. Whenever you create a primary key on a column, right, the index will get created behind the scene. You don't have to create the index explicitly. In the case of employee table, the employee column is get created as the employee number, right? That is the primary key. But net this query is outperforming than this one. So the flow we will discuss it later. At this moment, you understand one thing very clearly. First, understand the concept. What is, we cannot see all the time. We don't use the plain simple queries like this, right? These are the things. Okay, fine. But there are some business questions, business queries requires you to join more than one table. Fine, but there are some cases, you do the same table. You are going to use the same table, but in though you are using the same table, in the where class, you are doing some kind of aggregation. So, right, something like that. Okay. But when we compared both the non-correlated subquery and correlated subquery, both of them produce the same output. But whereas the performance is very bad when it comes to the correlated subquery, because for every record in the outer query, the corresponding record in your subquery will get executed. If you have 1000 records, for every record, right, 1000 times your subquery will get executed, whereas here the subquery get executed only once, right? So even you take this example, multiple row subquery, right? So even in this case, it runs 3 records. Only for 3 records, 3 times this record will get executed. The outer query will get executed. So writing the query or deriving the logic, right? Simply saying that to answer to a business query, you need to derive the logic in terms of the query. But your query might produce the output, correct output. That doesn't mean, right, your query is the best query or it is not the optimal query. So for that, you need to try writing the query in different way and see which one is better. End of the day, you go by the cost. But there are some times the cost is also not the single, based on, you cannot determine based on the cost. There are some cases, right? So you need to go by some other factors. At this moment, I'm not going to discuss all those things, okay? So now you understood what is subquery, nested subquery, multi-row subquery, and the correlated subquery, and difference between these two you understood, right? So fine. So in today's session we discussed about set operators also, union and union all, union and union all also we discussed, right? The depart number with this, let me do, yeah, union. Yes, we will try with union all also. I should have told you that time itself, but anyhow, so union all will have the duplicates. It should have the duplicate, but you know, it is getting all the records in both the all the depart numbers from your employee table and department table got combined together. But the union is, it is eliminating the duplicates. It shows only the 10, 20, 30, 40. That's all. So these are the difference between these two. I'll share this script to you also on the GitHub. We start practice it. Today I'm going to end this session little early, but tomorrow we'll continue with stored procedure. Okay, I'll explain you what is stored procedure, and then we will proceed, and then I'll show you once again how to install the demo databases like the AdventureWorks, right? AdventureWorks. This is data warehouse. You know, here you can see the Snowflake schema. Okay, AdventureWorks, DW209. AdventureWorks 2019 is the latest one. You can try this one. Apart from this, we have something called Sales LWT, LT, lightweight. Okay, Adventure lightweight 2019. So we will try install these three tomorrow, and then we will work on these three demo databases with some queries. So this one is kind of your real-time thing. Okay, orders table, all the things are there, and with that we will try it out and try to query all these things, right? And start with these simple queries, okay? So that, and start using in operator, any operator, all operator, right? So all these things you try to use it and then try practicing it, but don't get overwhelmed. You know if you get stuck somewhere, okay, don't worry. Over a period of time you will be able to understand everything. Okay, any questions so far regarding the topics whatever I covered? Okay, since you don't have any questions, tomorrow same time we'll circle back. Please do remember that my my mobile phone got damaged, okay, and I am using another mobile, and all of you, can you please share your contact number in this chat window, except those of you shared. Can you please share your contact number? Somehow I was able to log into the WhatsApp in my laptop, but after some time it was asking me to scan, but to scan it my display went off, okay. Or else, right, tomorrow same time you can join it, right? So if you don't want to share it, let it be there. So tomorrow you can share. I'll just show you how to do this one. I'll just go back here. Simply type download in the interest of others. Okay, AdventureWorks, right? Something like that. AdventureWorks 2019, something like that. Okay.
I downloaded it, sir.
Yeah, 1 second. I'll for the others, right? And if you click on this, it will take you to this website. And if you scroll down a little bit, right, so you can see the first two, right, or three, the LT. These three you can download it. If you click on it, it will get downloaded. Once this gets downloaded, very simple one, go to this C drive, whatever the software that you installed under program files will get installed, right? So you can see the SQL server here. Just click on it, and then SQL Express, you need to use that one. MS SQL backup, that's all. And this video also I uploaded it, the short video, in my website, right, in the playlist, whatever I share it with you, right? You can, so whatever the files that you download it, right, these three back files, you need to copy paste it under this folder, remember this. Once you copy paste this one here, don't worry about my, because I have so many copies here, you ignore all the things. End of the day you will have only 3 files, right? 3 back files you need to copy paste here. Next, go to your SMS and then go to click on the databases, right click on it, restore database, and here you'll find device and click on this one and click on add. So you select whatever the 3 files, right? First let's click on OK and click on OK, and that's it. So it will take some time. Look here, it got installed. It got installed successfully. Look here, done, right? So here you can see done here, progress done. That's it. It's very simple. So likewise, other 2 back files also you can install it. This is pretty much helpful because it has many tables. They did it for the real-time thing, okay? All the design, everything. It is really good. So this is the Snowflake schema, right? So you can install it, everything, and I'll give you a lot of queries tomorrow. We'll start work on that also after completion of the stored procedure, everything, okay? In the meanwhile, I'll share today's sessions SQL query also. We'll start practice this one also, all right? But make sure that you are creating the employee and department table first, and then you are inserting the data into these 2 tables, and then you start practice with these queries. It will be helpful, okay? And we'll share some more queries. Don't worry, start practice it side by side. Fine. All right, since no more questions, I'm going to end the session now.